Hi. With this video, I'm attempting to create the ultimate guide to variables in JavaScript. At the start of my career, when I had only a few years of experience, I could work easily with JavaScript. I could build my features, I could do whatever I wanted to do with it. But every now and then I would run into things that defied my understanding. A striking example that I still remember from back in the day is that when I would call a function with a certain variable and I would change that value of that variable inside of that function, sometimes it would affect things outside of that function, the call side. I would expect a variable that was copied and that I would only change a copy, not changing the original. This is not the case for certain variable types. Why is this the case? There are certain variable types in JavaScript. You have primitives and you have reference types or objects, and I'll talk about these in my video. Also talk about what pass-by value is. JavaScript is a pass-by value language. Lastly, I'll finish up with scoping and how JavaScript is a dynamic language. Let's get into it. JavaScript has 7 different primitives: undefined, null, symbol, boolean, number, big int, and string. Let's go over one by one. Undefined is used as the absence of a value. If you have a var statement but you do not give it a value, it is by default given the undefined value. You can also use the undefined keyword. The undefined keyword is a normal identifier. It is actually a variable. Secretly, you can change this to something else if you want to. It is not recommended, and in strict mode you will get a warning. In ECMAScript modules, which are strict mode by default, you will get a warning. But it is, in the old style of JavaScript, it is allowed in non-strict mode. There is one way to always get a undefined that isn't overwritten if you override it yourself. That is calling the void statement. Void 0, for example, is the shortest way of doing this. You get the undefined that is internally used by JavaScript. You cannot overwrite it. Null is a keyword that is not a value you can override like undefined. Undefined is not a variable, even though in my editor they both look blue. It's a different thing. Null is indicating the absence of an object. It is almost never used within JavaScript itself. If you have the absence of a value, if you are trying to run a find function or something else, then instead of getting null, you will almost certainly get a undefined back if you use something from the function from JavaScript standard library. Symbol is a new type with ECMAScript 6. It was introduced there. It isn't available in older languages. Symbol is used to create unique values, unique immutable values. They are secret unique identifiers that are inside of it. So if you call the symbol constructor, then you get a value that you can use as a key in an object property. So say you have an object, for z is object, you could use that symbol as a key for a property in an object. Talking about all the different use cases of symbols goes outside of the scope of what I want to achieve in this video, but suffice to say that they are a way to prevent name clashes. For example, if you want to work with mixins or private properties in objects or classes. Booleans, you're probably familiar if you're watching this video. True, false. You also have the Boolean function if you want to coerce things into a Boolean. You could also do this with a twice not operator. Numbers. So there is no difference in JavaScript between integers, complex, real, floats, doubles, etc. Many languages have all these different number types. JavaScript has just 2. It used to have just 1, but it now also has the big int. The number does have 2 special types, the not a number type and the infinity type. If you try to divide something by 0, which is obviously not allowed by mathematical laws, you get a infinity result. If you try to run parseInt on a string, it cannot do the conversion, it cannot convert it into a number, so it will tell you this is not a number. You can test for this. There's a is not a number, is none function. So big ints are integers without limitation on length. Numbers have a limitation on length. There is a number.maximum integer property. You can look this up if you want to. Big ints have effectively no limit. In reality, everything has limit because you're dealing with a computer with a limited amount of memory, but in practice, you will not run into this probably. And finally, strings. But in this video, I won't go into detail into what a string is, what it's made of, because effectively, it isn't that much different from a number. It is a primitive value. It is immutable in memory. I'll explain later what that means. Let's get into the more complex types first and then try and understand what's going on. Next, let's talk about objects. Objects are the other category of types in JavaScript. All the other things that are not primitives, there are usually complexer types. They're data structures. Every other type is an object. A function is an object, an array is an object, maps, sets, every other thing. So plain objects are key value stores. Everything that you put into an object needs to have both a key and a value. That value is, again, one other type. So it could be anything. It can be an object itself. It could also be a primitive. And the key is usually a string, but there are a few exceptions. In the case of an array, it's an integer. There's a few ways to create objects. One of them is with the bracket literals. There's also the object constructor, and any other type, of course, has their own constructor. So array, map, set, functions even have syntax for this. If you assign a value to a property, it is then available. Objects by default are mutable, so anything that is an object you can change inside that object unless you have frozen the contents of that object. Since ECMAScript 6, there's a feature where you can call freeze on an object to freeze its contents. Any change to that will either result in an error or no operation happening. Objects have methods by default. Anything that inherits from an object has things like key, value, a keys function, values function that can give you a certain view at its contents, or you can iterate over them if you want to. Do note that in the case of these keys or values or any other function you assign to a property, function is just a variable type, and this property is just a name, a string that a identifier, not a string, identifier you assign to this specific key. So at some point in the source code of JavaScript, there is a keys property and its value is a function. That function iterates over its own values and then gives you their key names as an array back. This would be something that you could implement yourself. Keys is only a property, its value happens to be a function, and thus it is callable. Next up, maps. Maps are just like sets and arrays, special types of objects, but they're objects in the core. They are ordered lists of key value pairs. So objects by themselves are not ordered. Plain objects have no order. Every time you ask for keys or values, you iterate over them. It could be a different order. Technically, there's no guarantees about the order of an object. They're not to be used expecting a certain order from an object. Arrays are objects too, and they are ordered too. So arrays obviously are a list of things. You can put anything in there. There can be duplicates. There can be, you can add things up front. You can remove them at the end. There's all kinds of methods on an array. There's different ways of constructing. There's a literal, the bracket syntax you can use. And again, it's good to realize here that arrays are just objects with keys as integers. They are not numbers. You cannot have keys that are decimals or whatever. They do need to be integer numbers if you add to them. You can actually add other properties to objects as well if you want to arrays as well, but you are then using an array as an object, which I guess is an anti-pattern. It's a bit silly because no other user would expect you to do that, but it's technically possible. And then you have sets. Sets are also sort of lists, but they are unique values. They are ordered list of unique values. So anytime you put something into it, it is comparing whether it already has that thing available. If not, it will not accept addition. It will not allow it, which is what happens here. 5 is already in the set. Set has a length of 2 at this point. If you add another 5, it still has a length of 2 at this point. So it's an easy way of making sure you have a list of unique values. This is highly optimized code in the source code of JavaScript itself, in the engine's implementation. So this is probably in most cases the fastest way to make a list unique, just convert it to a set. And finally, functions. Functions are objects as well. They're just callable. There's many different ways of creating functions, especially in the last versions of JavaScript. You have now also generators and async functions. But all these basic variants have been available for a long time, and they've always been objects. You have always been able to call the length property on a function to retrieve its number of arguments specified in the list. In this case, I'm getting the one from the m function, which has 2 arguments specified in the list, so it will give me 2. So you have function statements with a name in there. You have function expressions, because this is an expression that is then being passed as a value to this variable. You have anonymous functions as expressions. You have arrow functions as expressions with a single line body. You have arrow functions as expressions with body declarations. You have generator functions with the star at the end. And you have async functions, in which you can use the await keyword and which have to return a promise. In this video, I will not talk about classes or the this keyword or prototypes for that matter, because it's a very large topic. And if you look at it from a language feature perspective, classes are not a new type. They are a feature that was already available. Classes are just a different way of writing your syntax. They, under the hood, are just functions. Functions are objects, and you can assign properties to objects, which then again are functions. And that is all that a class is. It's just a function with more functions assigned to it. So it looks like a method, but it isn't anything special actually. Let's continue to pass by value. Pass by value is a language feature. It is referring to the passing of arguments to functions and the thing that is being passed being a value, not a reference. Not all languages, in fact, most languages aren't pass by value, and it's interesting to inspect what this results into, what features you get and what features you might not get from this. So JavaScript has these 2 types of variables that I explained before, primitive and reference. Anything that is not a primitive is a reference, also an object. And every time you create a new variable, you have a new value, a fixed amount of memory is reserved for this thing that you want to store, whether it's a number or a string or whatever. And you can store your number in there. This is why a number has like a maximum size. The default area allocated in memory to store that number has a size. And for an object, since that's a mutable type, it can grow very, very big. And therefore there is no default memory address that you can quickly reserve. So if you're implementing JavaScript, implementers of JavaScript have 2 different types to solve for this problem. They have primitives and they have reference types. And primitives are the basic types that you can store directly into memory. Anything that is a primitive has a fixed memory address, except for strings, but they're a special case. And anything that is a reference type has not a fixed amount of memory available. So if you copy a variable, and that can be passing a variable to a function, which is the pass by value, its in-memory value is copied. It happens to be the case that in-memory values of primitives are its actual values, and in-memory values of reference types are the reference itself, the memory address. So if you have a variable and you assign it to A, you create another variable B, which you give the same value as A, then the value of A is copied to the name B. And let's call A the identifier, B a identifier, and 13 a value. So the value inside A is being copied to the identifier B. So B, if reassigned, will be a different thing because it was copied in the end. If you look at reference types, you have the identifier A to which you assign an object. You don't know its contents yet. A only knows I am referring to a specific object in memory. I don't know its contents. It's assigning the reference to a new object. So the identifier B if you assign that the value of a, then the value of a is a reference to the object. So it's copying the reference of the object inside a to a new variable b, to the identifier b. If you then reassign things, the original is modified because they are two variables, both a and b, are referring to the same object in memory. So if you then look at its value, its original was changed. This is opposed to the first example, where the value that they were acting on is the value itself, instead of the thing they were acting on is the reference to an object. So that is why certain things are changed in memory and others are not. Next, let's talk about scoping. There's a few different ways to create a new scope in JavaScript, and there's a standard scope available already. There's the global scope, and depending on which environment you're in, Node.js or browser, you have a global or a window, and by default there's also the file that you're in. I'll go on to these next. So first, the global scope. They're basically the same for 98%. Node.js has some specifics and the browser has some specifics. Things like what is the file name on my disk, that is specific to Node.js, but something like a location, what is the URL that my current browser tab is running on, is obviously also not available in Node.js. So there's many other things defined on the global scope by default. Functions like parse int, but also the undefined keyword that is not actually a keyword but just a by default defined variable. This is all on the global scope. Another way available since ECMAScript 6 is block scope. It's not a very often used feature that I don't see a lot in the wild, but it's out there. It's a way to create a new scope from wherever you are. You can use this within a function, within a module, doesn't matter. If you use a const or let statement within that, it would function as a new lexical scope, a new block scope. This A is not available outside of it. If you would run this piece of code, it would return a reference error when trying to log this, but it would first successfully log the value 42, because this is defined within the scope. A is available here, but not over there. Next, function scope, with even example of a closure function. So we have a function over here that has its own variable defined within its function body, and therefore this is not available outside of the function scope. But it is accessing a variable that is defined in a parent scope, and it can access that. This is called a closure function. For every function that gets created, a closure scope gets created, which means the variables that are referenced, that are available in a parent scope, so inner can access outer scope, not the other way around, it will allow this. Then we have Node.js module scope and we have ES6 module scope. This is both per file. You are probably familiar with the require function that you can pull dependencies in from Node.js. You can either pull them from disk or in this case a package that you may have installed with npm, and the way to export them is on the module exports object. This is also called CommonJS, which is a standard. And for ES6 there is another way, more syntax was introduced. You have the import from and you have the export, and the export default syntax available, which is a different way to do sort of the same thing. It's just a standardized syntax. Now that we've talked about the basics of scopes, let's talk about hoisting. Hoisting is the act of variables that are defined via the var keyword. They are being pulled up into the file and being made available as undefined values before you use them. The practice was introduced at one of the first versions of JavaScript to prevent starting out programmers to run into reference errors all the time. So what they would run into is undefined values and their code would sort of softly fail on them. Nowadays it has been decided this is a bad idea. If we design languages nowadays, we use keywords like let and const to the features of let and const to immediately give the error to the user, because the user being the programmer, because the programmer wants to know when something is undefined. You don't want to figure this out in production, you don't want to softly fail. But by the original design of JavaScript, this was considered a good idea because JavaScript was only used as an optional enhancement in the browser. The main content, the main feature that the user in the old web was used to is just HTML and optionally CSS and very, very optionally some JavaScript. But this, of course, changed a lot. So if we have some variables here, A and B, we have a function that we call with this, then this function is defined very late on in my document. And this works. Why does this work? Because when JavaScript starts to run this code, it doesn't run it line by line. It first does a sort of pass of the code. It finds all the var statements and it finds all the function statements and it pulls them back up. So what actually happens is if I would comment this code and I would uncomment this code, this is what it would actually turn into. These var statements would be put up here with all the value of undefined, and the sum function would also be put up here, which is why if you start running this code in this order, it suddenly makes a lot more sense, because at the moment you are running the sum call, it has been defined. Whereas with the previous one, at this point in time, it wasn't defined yet, one would assume, but it is actually the case. This process is called hoisting. Let's also talk about the 3 ways you can use to create new variables in JavaScript. There's var, let, and const. Let and const are ECMAScript 6 and up. Var has been available forever. So var has the ability to define global or local variables, depending on whether you use it in the global context. And it does hoisting, like previously explained. Let and const are block scoped, and they allow or disallow the change to which value they're coupled. And here it's important to have a distinction between the value, the type of a value, and the name, the identifier of a variable to which a certain value is coupled. Let allows you to change which value they're coupled to, and const does not allow you to change. This is completely separate from type system. I will explain after this. They still allow you to mutate an object, as you can see in this example. Both of them allow you to mutate an object. So y has an object and you can reassign its name. This is fine. For const, z is an object and you cannot reassign the complete variable name. This will give you a type error. But what we can do is reassign a value inside the object. This is fine. This will not throw an error. This is also the case for this one, for let. The difference here again is that this works because the value of an object is the reference to the object. That is again, a primitive is its value itself, but for a reference type, it's the reference to the object. The object is somewhere else in memory and it is of unknown size. For the variable, it's fine to change its contents, even if it's a const. It's very important to remember. The concept of immutability is not what const is about. It is only disallowing you to change to which value you are assigning it, but it is not disallowing you to change the contents of a variable, if it's a complex variable. And finally, let's talk about how JavaScript is dynamic in 2 different ways. JavaScript is a dynamic programming language, and JavaScript has a dynamic type system. These are separate concepts. A dynamic programming language is the feature of extending program behavior at runtime. And this was of course necessary for when JavaScript was invented. Browsers would load script tags at a different pace. They're all asynchronous loading, and code would run at different times. So the program was extended at runtime. You have the ability as a JavaScript programmer to change objects at runtime, to change even the implementation of functions. You can extend objects, you can add code, you can do many things at runtime. You have the eval function available. You can modify the parts of the type system at runtime. All of this is due to JavaScript being a dynamic programming language, which was necessary in its environment. It allows for faster compiling, it allows for many features like I just mentioned, and it also allows for meta-programming, something that is also outside of scope of this video, but it is a feature that's available due to that. The next important feature is dynamic typing. Dynamic typing is about determining type safety and program correctness and the final types that are being used, determining all of that at runtime instead of compile time. Dynamic typing can be explained as associating types with values instead of names. So if you have a variable statement var a is 5, then equals 5, then you can think of it as the 5 is the thing that has a type, not the a. The name, the variable name, the identifier is not associated with the type. Only the value is associated with the type. 5 is a number, not a is a number. So this is really the way to think about dynamic typing. Yes, in the end, it will have to work with types because that's how programming languages work, that's how computers work, but it's not doing it at compile time so that you start your interpreter faster, so to say, so that you have all these features that previously discussed. This also means that type coercion is a big feature in JavaScript. It has been there forever. It's now being limited somewhat with ECMAScript 6 and versions after, where correctness is being built into the system. But type coercion is very much alive. Look at the plus operator, where if either side of the operand is a string, then the other one will also be converted to a string, and the plus suddenly becomes string concatenation instead of adding numbers. It is not asking you to do that. It is not failing so to it's just doing. This type coercion is built into the language in many different levels. It is not about protecting you when you've made a mistake. It is about not failing in production, because JavaScript was at one point seen and developed as the optional thing, the sugar on top. You can still get to your content without the JavaScript. It's just there as an optional thing. TypeScript is about associating types to names, to identifiers at compile time. Don't be fooled, TypeScript doesn't do anything for you at runtime. It is just working at compile time. Even if you're using TypeScript, at runtime you are not using TypeScript anymore. You are just using JavaScript, because the JavaScript interpreter, that is either Node.js or the browser engine that you're working with, they are determining which types are being used. And TypeScript is only there to assist you in your IDE, in your editor, to help you with better code completion, a better understanding of your code, and easier refactoring and whatnot. It is sort of gaining a theoretical correctness check, but it's never complete. And that's it. I hope you've enjoyed this. I hope this helps you in your quest, in your route to understand and appreciate all the features that JavaScript has to offer. If you have any thoughts, if I've made a mistake, if you have a request for something you'd like to see in the next video, let me know in the comments. Thank you very much for watching.